This section introduces a third way of reading a child at work in mathematics. Two lenses standardly read. A child doing mathematics. The cognitive lens asks whether she grasps the concept. The affective lens asks what she feels. Both are necessary, and neither is sufficient. Neither can say why she began, nor what made this particular move worth making. Sinclair's wedge is a third lens, orthogonal to the other two, the aesthetic. It is the sense of fit that instigates inquiry and appraises which idea is worth pursuing. The move that makes this work is relocating aesthetics from critic to producer, not from judging finished museum theorems, but from the act of making mathematics, the one act children genuinely share with professionals. The mother's conversion trick and Zoe's symmetry sort are the same primitive shown from two angles. This section explains the opening move of the book and the primitive everything after it runs on. Beauty in mathematics usually sits in the finished object. The theorem a professional deems economical, inevitable, unexpected. The opening move relocates that beauty from product to production, from critic to production. The aesthetic becomes a lens on the doing. It stops being a verdict on the done. That shift is what lets it reach children who produce mathematics even though they judge no museum. Two anchors carry the idea. A mother collapses 1.609 into 1 plus 0.5 plus 0.1. A girl sorts polygons by symmetry into a satisfying binary. The cognitive lens asks whether she understands. The affective lens asks what she feels. What both of those leave open, why she classifies it all. The aesthetic supplies. This is the primitive the whole book runs on. This section explains why the aesthetic belongs to every inquiry, not only to art. The Enlightenment cut cognition into faculties, the logical faculty for mathematics and the aesthetic faculty for art, and the move here is to deny that cut. The aesthetic is a pervading quality of any inquiry rather than a class of objects. It is the felt qualitative unity, in Dewey's phrase, that selects which features of a situation matter. It guides the unconscious pre-selection of ideas, what Poincaré called the sieve, and what Damasio called somatic markers. And it signals the moment when tension resolves into a whole. Once you locate the aesthetic in the act of ordering rather than in sunsets and sonatas, mathematics inherits an equal claim because it too proceeds by making disparate things cohere. The primitive is this: reclaim the aesthetic from where it lives to what it does, and every domain that seeks unity becomes aesthetic. This section explains why the aesthetic is a faculty that runs across all inquiry, rather than a domain sitting beside ethics and science. The Enlightenment filed the aesthetic under art, one cell in a partition next to ethics and science. Chapter 2's move is to dissolve that partition. The aesthetic is a faculty, a pre-selection operator that runs across all inquiry, Three thinkers mark the same operator from different angles. Damasio's somatic markers rank sense images before reasoning touches them. Poincaré's unconscious passes ideas through an aesthetic sieve. Dewey names the target: qualitative unity, the felt fitting of parts into a whole. Mathematics inherits the aesthetic through shared instantiation. Mathematics and art are both instances of one thing, a mind imposing order on the indeterminate, so the inheritance is direct rather than analogical. Reclassify the operator from what a thought is about. Polish is about to how a mind secures coherence, and the arts lose their monopoly. This section explains why beauty feels like pleasure. Beauty is not taught taste. It is the felt signal that a percept just compressed. The chapter's move is this: aesthetic pleasure is a fitness readout. Symmetry, repetition, and order. Please, because each one lets the mind reconstruct a whole from a fragment, and the shortest description wins the reward. Dissanayake making special, Wilson's epigenetic rules, and Gombrich's sense of order are one primitive under three names. The organism preloads an expectation of regularity, and pleasure fires when incoming stimulus is compressible against it. Hence the sweet spot, what Gombrich called delight, lying between boredom and confusion. Too redundant, and there is nothing to encode. Too random, and no code exists. This wires the book's central claim. The beauty of mathematics is not ornament. It is the same reward for successful compression. This part explains why beauty is the feeling of a compression from the inside. The chapter's move is to strip aesthetic response of its ornamental status. Aesthetic response is the reward signal that evolution wired to flag enabling acts, the perceptions that buy the most understanding for the least data. It is not a varnish laid over cognition. It is the mechanism cognition uses to know when it has found a shorter description. It is the mechanism cognition uses to know when it has found a shorter description. Symmetry pleases because half a face predicts the whole. The shortest description wins, and the mind registers that saving as pleasure. This is Disanayake's idea of making special, and Wilson's idea of the shortest description. Mathematics feels beautiful through the very same circuit, because mathematics is patterning, ordering, and balancing the exact acts the reward tracks. The pleasure of a clean proof and the pleasure of a symmetric face run on one wire. The chapter's place in the book is to ground mathematical beauty in biology so that it need not be taught in children. It only needs to be recruited. This section explains a shift in how to think about mathematical beauty. The chapter turns on one inversion. Stop asking what beauty is and ask what it does. Hardy chased objective criteria, economy, surprise, and significance, the kind any real mathematician could supposedly see. Sinclair discards the property for the function. She defines the aesthetic operationally by the roles it plays in live inquiry rather than as a quality residing in the theorem itself. Beauty becomes a pleasurable sense of fit, bound to the perceiver and the culture. The move the chapter turns on is this: that sense of fit factors into three functions. The motivational function is what draws you to a problem. The generative function is what yields ideas. Logic alone cannot. The evaluative function is what yields ideas, logic alone. That tripartite decomposition is the instrument. The aesthetic is what it does. The rest of the book will turn on children. This section turns the question of mathematical beauty on its side. Instead of asking which theorems are beautiful, it asks what beauty does. Hardy's error was to treat elegance as a predicate on the object. Economy, surprise, significance, all of it residing in the proof itself, legible to any competent eye. Sinclair's pivot moves the whole thing. The aesthetic is a sense of fit, perceiver relative, and defined by its function in inquiry rather than by any intrinsic criteria. Read beauty as a role rather than a property, and its structure falls out of the temporality of doing mathematics. It has to act before, motivating which problem to take up. It has to act during, generating moves that no logic yields, the mathematician who simply had to purge an unwanted -1. And it has to act after, evaluating the finished result. 3 roles, 1 lens. An object is what it does, turned on beauty itself. This section explains why logic alone does not determine mathematics, and names the operator that fills the gap. Logic underdetermines mathematics. The textbook picture, discovery, and then justification hides a prior degree of freedom. Which problem, which direction, which final form, none of them fixed by deduction. Sinclair's move is to name the operator that closes that gap, the aesthetic, and to show it acting at 3 distinct points as one mechanism. It is motivational, selecting the region of inquiry. It is generative, steering the search, reading the kissing angles 91.031 degrees as a clean 90 degrees because a neat relation felt likelier. Beauty is the selection function wherever logic cannot decide, rather than ornament layered on top of rigor. The rest of the book asks whether children run the same operator. This section explains why the mathematical aesthetic is necessary to inquiry rather than ornamental to it. Mathematicians name 2 stages of their work, discovery and justification. The aesthetic lives in a 3rd stage. They leave out, selecting what to investigate at all. This is Sinclair's move. Because mathematics has no external reality to check against, a point Timotsko presses, no logic decides which problem, which hypothesis, or which problem, which hypothesis, or which problem, which hypothesis, or which proof actually matters. That selection, made over an underdetermined space, is the aesthetics work, and it runs in 3 roles. The motivational role is the way in. The generative role lays down signposts through the terrain, guiding the path rather than delivering one leap to insight. The evaluative role weighs succinctness, symmetry, and connection over isolation. The claim the argument turns on is that this aesthetic is necessary. Strip it out and inquiry has no way to begin and no way to rank what it finds. The chapter is the hinge that turns the mathematician's aesthetic toward the students. This part explains why a mind moves toward a problem before it can solve it, and it locates that pull in the aesthetic rather than in cognition or feeling. That is the chapter's thesis. The aesthetic's first office is selection, a gradient over the space of problems that decides which ones a student moves toward and stays, which ones a student moves toward and stays with. Sinclair borrows Dewey's cut between attention caught and attention held. Caught attention is a bright surface, a grade. Held attention is drawn by simplicity that misleads, by surprise, by connectedness, and by the urge toward order and exhaustiveness. The anchors are 2. Tim, persisting a month against the 4-color theorem, and Christine at the task called meeting Lulu. The same qualities that draw professionals draw children. Motivation here is not a reward bolted on from outside. It is intrinsic attraction to form, the pull that precedes the work. This section explains where Sinclair locates mathematical motivation. Motivation ordinarily sits in affect or an extrinsic reward, marks, rivalry. Sinclair moves it instead to the aesthetic, the pull of latent structure itself. The distinction that carries her argument is Dewey's. Aesthetic qualities do not merely catch attention, they hold it, steering the eye toward relationships, toward patterns, toward what can be unified. 2 inclinations do the pulling. The first is the urge to impose order on the disordered. The second is the reach for exhaustiveness, the urge to generalize, to hold all cases at once. Two students anchor the claim. Tim, who refused the 4-color computer proof for a month, anchors problem selection. Christine, who abandoned Lulu's meeting for the shapes her traces make, anchors problem posing. This is the chapter's work in the book. Proof that students already behave aesthetically. Motivation is structural desire. The desire is the pull of the structure itself, not an ornament laid over cognition. This section explains the third role beauty plays, the one that works, while an inquiry is still running. Beauty here works as a selection function over the search space. It does its work during inquiry, choosing which path to walk before anyone knows where it leads. This is the least visible of the book's 3 roles, the motivational, the generative, and the evaluative. It is least visible because it fires fleetingly, often below awareness, pruning the tree of possible moves, faster than logic could license crows and anyone knows where it license. Papert's anchor carries it. Non-mathematicians, transforming the square root of 2 equals p over q, gravitate to p squared equals 2q squared, and they do so with visible delight, having selected the fertile equation without knowing it is the proof's next step. The response precedes the reason. The pleasure marks the path, and only then does justification follow. This part explains the subtlest of the 3 ways. Aesthetic feeling shapes mathematical thought. Before the logic that would justify a move exists, a feeling has already chosen it. That is the generative role Sinclair isolates, the third of her 3 aesthetic functions, alongside the motivational and the evaluative. An aesthetic response to a configuration steers inquiry down a promising path before the goal is known, often below the threshold of awareness. Casey's sense of symmetry, Sarah's craving for exactness, John's leap from a single case toward a general rule, each is that response at work. Against Poincaré's picture of a purely mathematical unconscious, Papert's square root of 2 experiment shows the pull can surface consciously and in non-mathematicians. Here is the primitive. The aesthetic is a prior over the search space, pruning directions before proof can verify any of them. Taste is the heuristic, and reason is the audit that follows. This section explains how the aesthetic works as an evaluator. Once truth is already secured, truth admits a proof. Beauty ranks the many proofs that are all equally true. The evaluative aesthetic is the selection function. Mathematicians apply once correctness is settled, the gate deciding what enters the canon. Sinclair's move is to deny that the selection lives in the object. Dreyfus and Eisenberg's objectivism fixes one ordering, the expert's ordering, and reads every divergence as deficiency. Students who prefer their own messy Gauss sum formulations to the neat one are judged aesthetically blind. But an ordering is defined only relative to a purpose. Brown students optimize a different objective. What they encode is their struggle, where the experts encode economy. Same theorem, different loss function. The chapter reclaims that difference as competence, where the objectivists saw only failure. This section explains what elegance really is, once you stop treating it as something a proof possesses. Elegance names a move a community makes rather than a property a proof owns. It is the third and most public function of the aesthetic, the one that gatekeeps the canon. Dreyfus and Eisenberg read students' failure to match experts as an absence of aesthetic sense. The correction the chapter turns on is that this presupposes an objectivist metric, some fixed ranking of simplicity, generativity, and cleverness, and no such ranking can exist because those criteria conflict with one another. reframe the classroom from adjudicating right versus wrong to negotiating worth, and something changes. Middle schoolers already wield the mathematician's own criteria. They wield them to persuade each other rather than to converge on the expert. Evaluation is relational rather than substantive. Beauty is what a judgment does inside a negotiation, never what an object contains. This section looks at what stays hidden inside the culture of mathematics. Mathematics looks value-free only because its values are the ones you have been trained not to see. The pivot of the chapter is this: the aesthetic sense that felt personal, until now turns out to be cultural. An individual's sense of what is right is circumscribed by a community's values. Those community values are Bishop 6, arranged in 3 pairs: rationalism and objectivism, control and progress, openness and mystery. Here is the primitive that carries the chapter. Mathematics' abstract, dehumanized surface is manufactured by a subtraction. Balachev names 3 Ds: decontextualize, depersonalize, detemporalize. Together they strip circumstance, actor, and time from what was a thoroughly human act. That stripping is an aesthetic preference, not a discovery of truth. It prefers cohesion over loose ends, object over process, permanence over flux. Naming the subtraction turns doing mathematics into enculturation, you can see, and therefore contest. This section explains where the beauty of mathematics actually comes from. In the earlier chapters, that beauty looked personal. Here it is revealed as downstream of something impersonal, the discipline's values, the set of relations to knowledge a practitioner is enculturated into. The step the whole argument turns on is this: a value is not a truth. That mathematics feels objective, timeless, absolute is itself a learned preference, not a property of its objects. The very human practice of doing mathematics manufactures dehumanized ideas by choosing to prize deductive rationalism, control, and openness over their alternatives. So the outsider's aesthetic response becomes a lens turned inward on the culture. It lets you grasp what mathematics is, locate the values that generate its beauty, and hold that they could have been otherwise. This section explains why teaching mathematics is a form of enculturation. Teaching mathematics is enculturation, immersing students in the values that decide what counts as mathematics at all. Chapter 10's move is that those values are never neutral. They carry an aesthetic, the pull toward the surprising, the general, the elegant, and that aesthetic is already operating tacitly in every choice of topic, task, and tool a teacher makes. So there is no adding beauty later. The selector was always aesthetic, just invisible. The chapter's whole work is to render that hidden selection function explicit, its intellectual appeal, its significant expression, so a teacher can choose deliberately what the curriculum already chooses by default. Make the tacit selector visible, and pedagogy becomes value-conscious rather than value blind. This section explains why teaching mathematics transmits an aesthetic whether or not the teacher intends it. Teaching mathematics works by enculturation rather than tool transfer. You hand students the discipline's values, and those values are aesthetic. Here is the step that does the work. This transmission is not optional. A teacher who never says beautiful still teaches an aesthetic. It is the anti-aesthetic. It's a mathematics as something that ought to leave you numb. So the only real variable is explicit versus covert, never present versus absent. Silence is itself a signal. The chapter swings the aesthetic lens around to face the teacher. That lens was built across the student cases and Chapter 9's account of the mathematician's culture, and here description turns into prescription. Its anchor is a contrast. Borween's graduate seminar, where the word beautiful surfaces a dozen times in an hour, set against grade 8 lessons where the word never once surfaces a dozen times in an hour.